So I'm often asked, what is a derivative? It is the instantaneous rate of change of a function at a given point. Now remember, rate of change is slope, so you need 2 points. And essentially what it is as you're doing the slope formula, if this x value is approaching the a value, getting closer and closer and closer to it, you are getting closer and closer and closer to the instantaneous rate of change. And that's why we use a limit for this, because it says x approaches a. Now, if x was to equal a, our denominator would be 0, and this would not exist because we'd be dividing by 0, and that would be bad. And we have various ways of dealing with that in a function. So let's take a look at an animation that I made to show you what is really going on here. In this animation, what I'm going to do is I'm going to take this second point and move it closer and closer and closer to the point at which I want the instantaneous rate of change, or the derivative. I want the derivative at x equals 1. Okay, so this is my a value. Now this x value is going to get closer and closer and closer and closer to the a value. It can't equal a because then my derivative won't exist, but I'm going to get closer. So as I slide this closer, you'll notice that this purple line seems to mimic the slope right here at 1 better and better and better. Take a look. It's getting closer, it's getting closer. I'm going to pause it there. Notice this purple line is now closer to the slope we would have. The x is closer to a. The purple line is closer to the slope we would have. So as this x value is approaching the a value, our slope gets closer and closer and closer. Notice the difference between this x value, and this 1 is getting closer and closer to 0. So if I was to slide it even closer, here we go, it's very much approaching this value. And if I slide it even closer, so that it's almost 1, it's like 1.14, it's very close. A and x are very close, and it's almost exactly what we would expect to see that tangent line look like. Now, I could slide it a little closer, but once I hit 1, notice the line disappears. It's because I'm dividing by 0. I'm not allowed to do that. So like if I do like 1.02, there we are, and I have my line again. So that's what we're talking about. We're talking the limit as this value gets close to a, as it's approaching a. We can calculate what the slope would be at this a value, this value that I want the limit for. So that's what a derivative is.